Okay, today we're going to talk about free fall, weight, and motion, and this is related to the law of gravitational force, which we've already talked about this week, so you should be familiar with that. So the first thing I want you to do is think about dropping a bowling ball and a feather from the top of a very tall building. Which one will hit the ground first? Explain your thinking. You don't have to write this down anywhere, just think about it, and we'll talk about the facts versus fiction regarding that experiment. Alright, so you should have your worksheet open for today's exit ticket lesson, the ET lesson. It says it's like 7 ET in it. And we'll be doing some guided notes like these where I will show you the word that goes on the blank and you will fill that in on your worksheet. And there's some other activities that you'll do as well offline. So go ahead and make sure that's open. If you don't have it open yet, press pause, and when you have it open, then you can come back to the video and press play and finish up. Alright, so when gravity is the only force acting on an object, it is said to be in free fall. So free fall is basically acceleration that's directed towards the Earth thanks to our good friend gravity. So we don't really need to worry that if we drop something it's going to fall up to the sky like these objects here are. That would be kind of weird to live in a world where we drop things up. It's kind of like somebody falling upstairs like on a fail video, right? In free fall, all the objects will actually accelerate at the same rate, which means they're going to reach the ground at the same time. So you're going to test that out. But before you do, let's think about an elephant being dropped and a mouse being dropped from the same height in an airless environment. What's going to happen is both are going to hit the ground at the same time. Because even though the elephant's 1,000 times the mass, it also requires 1,000 times the force acting on it to get it to the same acceleration. So the idea here is more mass is harder to accelerate, takes more force. So you have to have more force acting on that mass in order to accelerate it even more. Okay, so here's your activity. I want you to find any two objects in your house that you can find, and they need to have different masses, and they need to be something that you can drop without damaging your parents' floor or damaging the object, unless it's okay to damage it. But that's up to you and your parents. You got to decide that. But find two objects of varying mass. I want you to hold them up at the same height, as high as you can, and drop them at the same time. I want you to watch really closely when you do and see which one hits the ground first. Then when you're done doing that, you're going to explain what you observed and explain why it didn't fit in with what we just talked about regarding free fall. Because your results are going to be different than what we just said your results should be. So what did you observe? So I want you to write down on your worksheet somewhere what happened and why you think it happened that way. Alright, so back to some more guided notes. So in the atmosphere, this is going to explain why you saw something different than what you expected. In the atmosphere, objects don't actually fall at the same rate, and there's a reason for that. It's because air, or the gases that are in the air, provide resistance because they're made of molecules, those gases. And so this creates some friction on the object. We call this type of resistance air resistance, which I'm sure you've heard of before. But you may not have known that air resistance is simply the friction that is provided when objects are falling through air. So no object ever actually experiences free fall, including skydivers. They say they're going out to do a free fall. I'm going free falling today. Well, they call it that, but that's not really an accurate description of what they're doing. So let's think about that, and let's dig into that a little bit. Objects that are orbiting in space actually are in free fall, as opposed to the skydivers that are jumping out of planes. Astronauts that are in space floating around, they're actually in free fall as well, but it's not because they're weightless. So let's think about the moon, right? We know the moon orbits around the Earth, and it's a very far distance from the Earth, but there's just enough gravity pulling on it to cause it to move in two different directions. It moves forward as well as falling towards the Earth. There's an illustration in the corner that shows you the path of the moon around Earth. But the force of Earth's gravity is actually pulling the moon directly towards the Earth. And the motion of it moving past the Earth in a straight line, we're going to look at that a little closer here in a minute, is actually combined with the force of gravity to create this orbital arc around the Earth. So what the heck am I talking about? So here we have the space shuttle. This will explain how we put things in orbit like satellites. So line A is this line here. It's a horizontal line, it goes straight, and that's the motion of the shuttle. That's the direction that it's moving, and it's moving at a constant speed. And if it were to continue following this path without any gravity acting on it, it would just keep going straight and eventually be light years away from the Earth. But gravity is acting on it, and it's pulling the shuttle directly down towards the center of the Earth. And if it weren't moving forward at the same time, it would eventually crash into the surface. But both of those motions are taking place. It's moving horizontally and it's moving vertically towards the Earth at the same time. This creates a path that we call an orbit. That's this curved path in the middle. So basically, the spaceship, the shuttle, is just continually falling around the Earth. It's always falling, but moving forward at the same time. That's the same thing that's happening with the moon. So here's your exit ticket. The question is, what are the two things that gravity depends on? So you're going to write those things down. We covered them in the guided notes. And then you have a short lesson to work on. It's about 5 questions. Some of them related to universal gravitation, and some of them related to gravity.